All right, this is Translating Conics Day 2. Today we're focusing on translating ellipses and hyperbolas. So these are the two general formulas you'll need to focus on. These should look familiar, except for that they are now have a different center. So they have different centers at HK. So again, we have the ellipse with the center or the horizontal axis, or our a value is under the x, or we have the vertical axis with our a value or a bigger value under the y. Or we have the hyperbola that opens right and left with the x squared comes first, and then we have the hyperbola that opens up and down or vertically with the y squared comes first. Again, the HK is our center, H always goes with x, K always goes with y. So that's what we're focusing on today. So here's our first example. We want to identify the vertices and the focus of the ellipse. So first of all, I'm going to pick out my center point. That's going to be my HK. So I'm going to have a center. Remember, the H always goes with the x, and the K always goes with the y, and it's always opposite. So if it's x plus 4, the center will be -4. Y plus 8, the center will be at -4, -8. Then, since the bigger value, or the a squared value, is under the x, my ellipse will be a horizontal ellipse. It will be more wide that way. Sorry. So then this is my b squared value. So if a squared equals 225, then a will equal 15. Which means then these points, right here and right here, will be plus 15 away from the center, and then minus 15 away from the center right there. So if I think about that, my vertices will be, remember this is -4, -8, so -4 plus 15, one vertice will be at 11, -8. Or if I go -4 minus 15, the other vertice will be at -19, -8. Then for an ellipse, I have my co-vertices. It doesn't ask me for that in this particular example, but the co-vertices would move plus or minus b units from the center on the y-axis. So you'd go up 12 or down 12 from the -8 point. So b equals 12. So that's from on the y-axis this time, so up 12 or down 12 to the co-vertices. So that's going to be the points -4, -8 minus 12, so -20, or -4, -8 plus 12, which would be +4. Okay, the next thing it wants is the focus, or the focus, yeah, the foci. It is plural, so foci. There we go. Which means I need to find the AC value. So if it's plus here, it's going to be a squared minus b squared equals c squared. So that's going to be 225 minus 144 equals 81, which is c squared. That means in this case, c is going to be plus or minus 9, or c is going to be 9. Remember, that's going to always be, the focuser is always on the major axis, which is the x-axis right here, the x way. So from our center, from the x value, it's going to be plus 9. So we're going to be at -4 plus 9 is 5, -8. And then -4 minus 9 will be -13, -8. So I went plus or minus 9 from the center point, -4, -8 on the x coordinate. It makes a lot more sense, and it's easier to follow when you do it with a graph at an example, so let's try this one. So this time, the bigger number is under the y. That means that this parabola will be horizontal, or more stretched vertically, more vertically stretched. That means that this is my a squared and this is my b squared. So my center will be at the point hk. H is always with x, k is always with the y. So hk would be negative 1, 5 in this case. Then I have a squared equals 9, so my a value would be 3. And I have b squared equals 4, my b value would be 2. I can use these values to find my vertices. So if you look at the picture and you start with graphing the point negative 1, then you know the vertices are going to be along the y vertically, and that's going to be plus or minus 3. That's my a value. So that's my distance from my center. So I need to go up 3 and down 3. So those are my two vertice points. That's the point negative 1, 2, and negative 1, 7. So I moved on the y coordinate plus or minus 3. I'm sorry, that's going to be negative 1, 8. There we go. Then co-vertices will be plus or minus 2 away from the center in the horizontal direction. So plus 2 from the center here, minus 2. So that's this time the x coordinate will change. So negative 1 minus 2 will be negative 3, 5. It's that point right here. And then negative 1 plus 2, so 1, 5. That's that point right here. So it's easier to see once you have an actual graph to go up and down 3 or right and left 2. Then the last step is to find the foci, in which case we need that a squared minus b squared equals c squared. So we have 9 minus 4 equals c squared. So that's going to be 5 equals c squared. So c is going to be the square root of 5. So our foci will be at negative 1. They're going to stay negative 1. And then it's going to be from the center up the square root of 5. So if you think about the square root of 4 is 2. So this will be just over 2, maybe 2.1, 2.2, the approximate. So you're going up just over 2 or down just over 2. As points, we're going to start at the 5 and we're adding the square root of 5 to it. Or we're starting at 5 on the y coordinate and we're subtracting the square root of 5. So that's what I did. I started at 5 and I went back square roots of 5 and I went up square roots of 5 to get those points. And then we do expect you to leave them in standard form or as points right here. Okay, this is a hyperbola example, and we're looking for the center vertices foci of the hyperbola. So first notice that it starts with x squared. So I know it's a hyperbola especially because I have a minus here. Since it starts with an x squared, it opens left and right. It's like two parabolas that open towards the positive x's and negative x's. Along the x's anyway, it opens left and right. It's going to have a center of hk. Center h is always with the x, k is always with the y. So the center will be 5, 9. So then, in this case, a squared in the hyperbola always comes first. So a squared would be 144, which means a is 12. And b squared is 256, which means b is square root of 256 is sorry, the square root of 256 is 16. There we go. We don't actually need to find this value because we just need our vertices, which are going to be from the center to the a value, or from the center plus and minus a value. So we really don't need the b value at all. But I'm just used to finding it. When graphing it, it's helpful anyway. So if I wanted my vertices then, again, it opens to the right and to the left. So if the center's at 5, 9, like let's say the center's 5, 9, you have to go to the right 12, so that'll be 5 plus 12 will be 17, we'll still be at 9, and then you have to go minus 12 back the other way. So 5 minus 12 is negative 7, 9. So those are my vertices. And then if I want to find my foci, similar to finding the focus in the foci in the ellipse, except for that it's a squared plus b squared equals c squared for a hyperbola. The equation is minus, so this one is plus. So that's 144 plus 256. That equals 400, so c squared equals 400, so c is 20. Again, the foci are going to be a distance of 20 from the center and 20 left from the center. So that means the x-coordinate, 5 plus 20 will be 25, 9, and 5 minus 20 will be at negative 15, 9. Will be the foci. So we found the vertices, foci, and then the center was right here. Okay, another hyperbola example. Again, this one, we look first to see what this means it's going to be up and down. It has a center HK, but you have to remember the H always goes with the X value and the K always goes with the Y. So this center will be 3, 9, because the H is with the X value. So that means our A squared value comes first in the hyperbola is 49, so our A value will be 7. So for our centers at 3, 9, our vertices will be a distance of 7 above and 7 below that center point. And that's just kind of nice to imagine that, because when finding the vertices then, you are going up 7 from the y coordinate. So it'll be 3, 16, and then down 7 from the y coordinate, and it'll be 3, oops, there's that random line there. 9 minus 7 is 2. So those will be the vertices from the center up and down 7. And then to find the foci, again, we need to use the equation a squared plus b squared equals c squared. So it'll be 49, b squared is 4 equals c squared. That's 53, so c will be the square root of 53, which doesn't reduce the square root of 53. It's a prime number, so the y coordinate or the x coordinate stays the same, and then you have to go from the y coordinate up the square root of 53, and from the y coordinate down the square root of 53. So you go 9 plus, the square root of 53 is going to be just over the square root of 49, so maybe 7.3 approximately. So you're going from 9 up 7.3 and from 9 down 7.3 to find the foci points to graph it. But we'll leave it in standard form right here, in exact form, like that. All right, let's actually graph one. So we look at this first. This is telling me that it's going to be opening, on the x. So it's going to be opening left and right on the x-axis. So I'm going to start by identifying it as a hyperbola as well, because it's subtraction and then it opens left and right. Our center will be the point HK, which H comes with the x, so -2, and then K comes with the y, so -3. And I'm going to find my A squared value will be 9, my A then will be 3. I'm going to use that to find my vertices. Having the picture here will be helpful as well. I start by graphing the center -2, it's 3. we're opening to the x-axis, so to the right and to the left. So that's 1, 2, 3 this way, 1, 2, 3 this way. And you can see that's going to be the ordered pair 1, -3, and -5, -3. And if you took your x-coordinate of your center and added 3 and subtracted 3, you'd get these points as well. And to graph the hyperbola, we do want to make a box here. So I do need my b value. So b squared is 16, so b is 4. So that means that I go up 4 and down 4 from my center. That's going to just help me sketch this box around these 4 points. That box just gives me an outline of what my asymptotes look like. The asymptotes go through the center and through the corners of the box then. I can write the equation of the asymptotes by using the slope-intercept or point-slope form. So y minus y1 equals m times x minus x1. So a point that we could use for x1, y1 might be the center, -2, -3. So x1, y1. And the slope is just rise over run. So it's up 4 over 3. So up 4 over 3. It's slope 4/3. This slope then is -4/3. Down 4 over 3. So the equations of the asymptotes will be y minus y1, so y minus -3 or y plus 3 equals 4/3 x minus -2 or x plus 2. And then the other equation, same point, it goes through the same point except for it has a negative slope. So those are the two equations for my asymptotes. So I have my vertices. I can find my foci now. So I'm going to use, to find the foci, I'm going to use a squared plus b squared equals c squared. So a squared plus b squared equals c squared. Where a squared is 9, b squared is 16. So that equals 25. So c equals 5. So from my center, just want to scroll back up real quick. And to make sure we're opening on the x-axis, yeah. So the focus is 1, 2, 3, 4, 5 here, and 1, 2, 3, 4, 5 here. So this is my vertex. I got to follow that asymptote to the right and to the left. And then from my vertex, follow the asymptote. It's going to approach this line, get very, very close, but never cross. And then I had my 2 focus points right here. Those are the ordered pairs 3, -3, and 1, 2, 3, 4, 5, 6, 7, -7, -3. C was 5, so from the center, you could go +5 to get to 3 and -2 minus 5 to get to 7 as well. Another way to find the focus there. All right, write in the equation. So if I sketch this graph here, I have vertices at 8, 9. So 8, 9 way up here, and -2, 9 up here. So that tells me that this is an ellipse that looks like this because my vertices are horizontal. So I can find the center then by trying to find the middle of these 2 points. So I'm going from 8 to -2. So the distance between 8 and -2 is 10. Cut that in half, and you have a distance of 5. So that means A is 5. So, because I have negative 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. So 10 total, cut it in half is 5. So then 1, 2, 3, 4, 5 would be right here. So my center is going to be the point 3, 9. So I have my A equals 3, or I'm sorry, A equals 5. I have A squared equals 25. I know my center. Process of elimination is 3, 9. That's going to be my HK and my equation. The only other thing I'm going to need is my B squared value. So it does give me my focus points here. That will be helpful. So if I graph those, so I have 7, 9 right here. That's my focus point. And negative 1, 9 right here. So the C value will be this distance from my center to here. So from 3 to 7 is a distance of 4. C value is 4. That means C squared is 16. So I can use A squared and C squared to find my B squared. So it's an ellipse. So it's A squared minus B squared equals C squared. I know A squared is 25 and B squared is 16. So I'm going to subtract 25 on both sides. I'm going to equals negative 9 or B squared equals 9. Then using my general formula, plugging it in, you have x minus 3 squared plus y minus 9 squared equals 1. And then the a squared value, since it opens on the x, will be under the x value, the bigger one, so 25, and then 9 will go under the y squared. So I plugged in HK for the center and A squared and B squared in their appropriate places depending on how the ellipse opened. Okay, so that's a quick this is a hyperbola. We have vertices at 5, 0 and 5, negative 4. Since these are my vertices, that means that this hyperbola must be opening up and down because these are vertical vertices. That makes sense. So that means we're going to have y squared over a squared minus x minus h squared over b squared equals 1. I need to find the center, so the distance between these values is 4, so that means, so from 0 to negative 4 is a distance of 4, so that means my center's got to be right in the middle, which means it's from 0 to the center, that distance of 2, that'll be my A value, my A distance. So A is 2 units, so A squared will be 4. Then it gives me my foci again, so I can graph those. That's 5, 2, and 5, negative 6. So the distance from the center to the foci is your C value. That's a distance of 4. So C equals 4, C squared will equal 16. So I can use that to find my B squared value. So it's a hyperbola with a minus, so it'll be A squared plus B squared equals C squared this time. So 4 plus B squared equals 16. So B squared equals 12. So I'm plugging everything in. I'm going to get the center. Oh, I never wrote that point. The center is this ordered pair that I found here. It'd be 5, negative 2. So HK. So final answer, y plus 2 squared over a squared minus x minus 5 squared over b squared equals 1. I And that is it. Remember, you can pause this at any time if you have questions. Hopefully I was clear enough. Let me know. Thanks.